Okay, so my name is Veronica Lopez. I come here from the Go community, where I have given a lot of talks. But right now I'm here to talk to you about my journey from Go to Elixir. Spoiler alert, I'm still working with Go full-time. But yeah, this will be a very simple talk, straight to the point. I will try not to repeat technical information that you can find everywhere else. I will not repeat what Elixir can or cannot do, because there are many talks about it already, or maybe in this conference or past years or whatever. And I am not going to show off with Go either, right? I'm just going to tell you, in my experience, what has worked for me and my teams, and to be more productive as a developer. So who am I? I am Veronica Lopez. I'm a senior software engineer. Previously, I was a scientific computing expert, and I used to work with mobile, but nowadays I am focusing strongly on distributed systems. And on Monday, I'm joining CoreOS. So yeah. That's why maybe if you know someone at CoreOS, they might not know me yet, but yeah. And I'm a gopher flirting with Elixir. So, first of all, what this talk is not about, defining a winner. And you won't hear me say Go is better than Elixir, or Elixir is better than Go, or nothing like that. I won't trash people's work, on either side of the aisle, because it has been super helpful for me, both languages have been super helpful for me. I won't do benchmark comparisons, because there are a lot of them, and that's always super tricky, because in my experience, when we criticize one point that hasn't been productive to us, there's always someone in the world that has found a workaround towards that, and then I will just show a benchmark with milliseconds, and then someone would tell me, oh no, actually you could fix that way. So that's always tricky, so I won't do that. And it also depends a lot on the type of system, your needs. It depends on a lot of stuff. I won't do profiling comparisons either, nor syntax comparison, because everybody has already been doing that. Also, this talk is not the objective of this talk won't be oh, Elixir sucks because it's not Go, basically, or the other way around. And this is not an official guide either, for repeating step by step what I did for your teams, because it might work or it might not work. It's just basically my journey from Go to Elixir, and this journey hasn't been just one way. It has been a round trip several times. And it has always been out of necessity. So I have worked for a long time. I mean, I'm based in Mexico City. So even though I have worked with North American companies, development in Latin America is not as you know it in other parts of the world or first world countries. Developers in Latin America, we have to be extremely resourceful, because our bosses, well, there's my former boss here, but our bosses tend not to be technical, but they are often business people. So you have to be very resourceful, very straight to the point for what you need and stuff like that. So I will tell you a story in a few seconds, but Elixir and Go are super cool for this, because they make you use resources in a more productive way. And well, I will tell you more about this. Now, this talk is also about use cases based on the best features of each language. And time and again, not Elixir is better or Go is better. And the thing that I'm going to focus on is the concurrency. Because these two languages, as opposed as, let's say, there are many talks comparing Ruby to Elixir, Python to Go, etc. But I don't think that those comparisons are strictly fair, because the languages were built for different purposes, So in this case, Go and Elixir were built, though with different specifications. They both were built for infrastructure, for telecommunications, for distributed systems, for concurrency. So I think that this comparison is a bit more fair than others. So here we go. No pun intended. Okay, so I'm going to focus on 3 main points. The origin, scalability problems, then pros and cons of of every language, but of every language at each different use case, and some final thoughts. As I've said, this talk would be super simple, straight to the point. Because a lot of times I run the Mexico City Go meetup, and well, here my former boss, Norberto, runs the Elixir Go meetup in Mexico City. So we often get the same questions like, when is Go better for? Or when should I use Elixir? And we always go back and forth to each other's meetups. So I pretend this talk to be like some sort of very simple reference to, I don't know, to real use cases. Okay, so it all began some years ago when I was leading a backend team in a digital agency in Mexico City, and we had scalability problems. So this is the tales all this time. Everybody who has systems or even websites running nowadays, they face this. So as I mentioned, there are many talks in the internet, many blog posts about how teams used to be working with Ruby or PHP or Python, and suddenly they had to grow. They started growing like crazy, and these languages were not enough. So they decided to go with Go, Elixir, or Rust. So just to mention, for reference, these 3 blog posts are the ones that have helped me the most. The case of parse, well, the extinct parse, but it's still useful from a technological point of view. Then the Iron.io use case and Basecamp, etc. Well, in the case of Basecamp, they still use Elixir, Ruby, and Go. So that's a very interesting use case too. And well, also when people have scalability problems and they have to replace their tools with new ones, they usually need to do this fast, as fast as possible, because that's the original problem to begin with, right? Because when you start having much more customers than you expected, or I don't know, any type of problems related to distributed system scalability, you often don't have the time because everything is on fire, right? So, oh, yeah, this works. Thank you. Okay, so our problem, my problem, when I was leading this team, we had tiny or small websites, decent-sized websites, some highly concurrent websites, but these highly concurrent websites were from very important clients like banks or, well, people with money. So, and we also had very limited resources, we had a very limited amount of servers, shared servers even, what I was telling you about development in Latin America. And all of our websites and services were written in Python or PHP. So, of course, these 2 languages are not ideal for concurrent systems, regardless of your preferences. So, being a digital agency, nothing was really built on purpose with concurrency in mind, And this was not bad at the beginning, because being a digital agency, the main focus was UX and everything that is shiny and new and usable, and things that sell. But what they didn't think about was that once concurrency starts misbehaving, the UX also gets sacrificed, like latency problems, huge queries taking a long time, not denial of services even, So, well, when I got there, this problem was already there. I didn't build it, but still, I'm not here to trash anyone, and I'm sure that this has happened to you all in your careers as well. So the fast solution was to acquire more servers temporarily, at least just to have more bandwidth to be able to work and not having downtimes for very stupid reasons. And also another solution, would have been to rewrite components, not rewriting everything, but just components. But unfortunately, neither of these were options, because first, since we didn't have a technical boss, it was like, we don't have money for servers. I mean, we had money for ads, for a lot of visibility stuff, but not for technology. So he was like, yeah, just be resourceful with what you have. So, and we also couldn't rewrite like components because they were Frankenstein monoliths, not very easy to rewrite independently. And we also were a very small team. But we were brave, though. And so the realistic options that we had were unethical ones, such as, let's say that we had shared websites on a single server. So what we did when we had high loads on very important websites was to take down all of the other websites, all the small websites. I mean, nobody ever complained because they were very small, but yeah, we had to do that. We also had to, cache. Many things were made in Drupal, PHP, so Drupal works, their idea of distribution of services, caching everything and just serving cached versions of the content to everyone else. So in the end, yeah, we load balanced, we took sites down, we did very ugly things. So yeah, there was a lot of shame. But well, also, we didn't have many options. So once we had like a little bit more time to think, and also we were like a distributed team, like physically distributed team. So that sometimes was not ideal, even though I love distributed teams, but in this case it was not ideal. So our real options were rewriting things, but not just components, but everything. And we had a lot of restrictions. One of them was that since it was a bank, they had restrictions on many things of security, including permitted programming languages. So we couldn't just go there and tell them, oh, we're going to use Go, or we're going to use this new language called Elixir. So they were like, no, you have to use Java, PHP, or I don't know what. So it was like, okay, Java is like the cleanest thing to do concurrency, but we hated Java, so that was out of the discussion. Then what we ended up thinking of was, instead of rewriting the systems or the websites, was how about handling them on the server side, which especially Go, in my opinion, is super good at. Elixir was also a very great option, but the thing is that Go won, but only because it was easier to adopt into our diverse team. And with diverse, I don't mean gender, but of backgrounds. Like, we had people that that were self-taught for coding, that didn't go to school, so they didn't have a lot of backgrounds on data structures, all those things that might be easy for you or natural to you if you go to school, if you went to school to learn this stuff, but not for them. And also, we were a very small team, so yeah, Go was the solution because of it, but also because it was famous. It was still growing, and it has like a huge community and stuff like that. So ever since I fell in love with Go, and it has only gotten better and better and better with time. It has amazing tools, an amazing community, amazing people. So this is the end of the talk. Yeah. But what about Elixir? Okay. So let's go to the pros and cons, which is super, super, super simple. So it's difficult to do concurrency correctly. I mean, I know that I'm not saying anything new, but yeah. So on one hand, we have Go, and on the other hand, we have Elixir. So let's keep in mind here that I'm talking in the context of a developer that builds distributed systems, not websites, not any other kind of things that I will mention like towards the end of this talk. So Go was built based on the paper by Tony, I don't know if I'm pronouncing it correctly, but Tony Hoare, CSP paper, okay? which is basically based on message passing, such as many languages out there. But, well, there are many languages. Maybe this is not the case for you, because if you learned Elixir and if you work with Elixir, you really don't have any problem with obscure languages. But for people out there, like, that work with more mainstream languages, there are many languages that, well, adopt the message passing philosophy. Then, okay, this got auto-corrected for coroutines, but well, coroutines are to threads, and channels are to mute access, let's say, in this philosophy for concurrency. Then Go's runtime multiplexes Go routines into OS threads and manages their scheduling. So this works like somewhat similar to Elixir processes, but a very beautiful thing that Go has is that, as it says, an OS thread can be attached, no, the other way around, sorry. A Go routine can be attached into an OS thread or not. Like, a single OS thread can host 1, 2, 10, 100, 1,000, a million Go routines, and it's super cool to use. So, well, you might say, yeah, but we have processes. And yeah, you do have processes. And that processes, well, are the building blocks for the fault tolerance, which is what made me take a look into Elixir. And the description of this talk, I said something like, as a golfer, I used to look at Elixir from a safe distance, yeah, right? But once I knew about the built-in fault tolerance, it was really day and night for me. Because maybe at developing websites, maybe, I mean, I'm not a web developer, so I'm sorry if I'm just saying things that I don't understand. But in my experience, like, for distributed systems, like, fault tolerance has to be there without any discussion. So it seems that not all golfers are even aware that this exists, not just like in Elixir, but in any language. They just think that that's not possible, and it shows. Like, I remember 3 years ago, when I was looking at Go books, a lot of them thought that they were the only ones as a language with a proposal for distributed systems and concurrency, and I was just like, haven't they heard about Erlang or Elixir? Are you serious? Am I the only one not getting what they're writing here? And I was not even an expert in the Beam languages. So here we have some examples. So I tweeted, fellow golfers, what do you use for fault tolerance? So, patience, tacos. There was another response that didn't make it here, but it said something like, tears during my own calls. Oh, yeah, it made it, sorry. So, my tears during on-call. But, well, this is actually a very good response. I mean, she works at the Go team at Google. So her solution for this is designing systems that fail well. Latency and fault tolerance, however, are all in-house built solutions. And that's the problem. I mean, you already have to worry about the architecture of very big solutions, very big software, pieces of software. And also, in my opinion, if you're using a language like Go or Elixir, you're probably building something that is built by many engineers, by many distributed teams. It might be geographically or, like, small teams that contribute to one large project. So in order, I mean, this team cannot be responsible for the failure of this team just because something so simple, right? So I don't know. So, and, well, on the other hand, this is in my very personal experience. I mentioned that I am not a web developer. I'm originally a physicist, so my journey to programming was not like the typical of maybe learning JavaScript first or HTML first or anything like that. So I went straight towards systems because that's what I knew. My background is on Linux and stuff like that. So many times as a developer, you find yourself trying to make a website, like even if it's for a very basic level or for really important things. So my experience has been like in the middle somehow. So every time I try to get into web development is like a road of suffering and pain. So the two options that I have always worked with are Rails and Django. So since I was a scientific computer scientist, Python is like more natural to me. But the point with this is that, as you might have heard in many talks, or maybe your experiences in particular, that you might use Rails to work super fast, but that doesn't scale necessarily. So that's maybe your case why you came to Elixir. So that was exactly my case. Once I learned about Go and I was super comfortable with the language, the available tools for web development are pain. I mean, it's super, super hard for someone. I am trying to be empathetic with someone trying to learn how to code with web development, as many of you or many developers around the world do. So with coding websites with Go is super hard because you have a lot of tricks, a lot of hacks that when compared to, let's say, Ruby on Rails, you don't. Like, you even have to worry about, there's this very popular Go website generator called Hugo, which is super cool. In 5 minutes or under 5 minutes, you can have like amazing websites that are compatible with Go. However, the more granular it is, the things that you need to do, it is like ridiculous what you have to do just to change a number or a color or anything like that. Then, as I mentioned, we always had like Django or Rails or even the PHP frameworks, but they're not powerful as, like, let's say Go, because maybe a lot of developers would say like, oh no, but I really like how powerful Go is. So I found, I don't remember how, I learned about Phoenix, and that was actually the reason I got into Elixir development, because I was like, okay, I was so frustrated with the available options that I was just like, okay, let's try this Phoenix thing. And it was not only easy, but it was super powerful. So it was just like, I got mind blown. So when I was preparing this talk, I discovered another tool made by a colleague, well, a fellow golfer, that is called Go Buffalo. It's a new framework. I haven't tried it yet. People say that it is way better than the available options. But I mean, I haven't tried it yet. So, and I don't know, maybe it will be the direct competitor or direct option or alternative to Phoenix. But well, yeah, that's something. But I didn't include this in the talk because it's a very simple and personal experience that might not be eye-opening for anyone. But now that I am talking about this, I want to share it with you. So I started building as a side project this website to rate makeup and beauty products in Latin America, which is super useful. So, because there's an array of products everywhere, and you don't know what works for you, not just from the vanity aspect, but safety, you know, all those things, you know. So I saw that there were many sites like this in the US, and I decided to do the same for Latin America because I'm a huge consumer. So yeah, I decided to first do it in Go, and I never finished that. So I then went back and redo it from scratch with Phoenix, and I won't say that it was all great, but because that was also my way to learn Elixir and the syntax and get familiar to everything, but it was way easier and powerful. I mean, I don't have concurrency problems yet in my website, but well, I know that if sometime I have those problems, it will be ready for it, and I won't have to build things again. Okay, so I went a little bit too quick because I was very excited about this. But okay, so the final thoughts. So you might have always heard, like, it's not the language, it's the programmer. So I hate this. Because, of course, I mean, I know what people mean when they say that it's not, when things go wrong, it's not about the language, it's the programmer. But also, like, yeah, I don't have to, I think that I shouldn't have to explain this anymore, like, to anyone, because, yeah, I mean, we can do anything in assembly or whatever tool that you like, right? But when you have very powerful tools such as Go or Elixir to build amazing things, there's no question. So now the second question is, why don't we have both? Okay, but how? So when I was making my research for the fault tolerance thing in Go, that is really non-existent. Like, in case you are interested about this, you can find many resources on the web, but one very popular tool is Hystrix, that you might have heard of it, that it was developed at Netflix. That is widely used for Java and well, now Go, to fight or to tackle fault tolerance issues, right? But there's another thing that you could also use. I've seen teams, and I've done this myself, working with Go, like the actual business logic of your product or of your system built with Go, but wrap everything with Erlang supervisor trees. So each of these nodes can be like either written in Go, written in Erlang, written in Elixir, or whatever you like. So that's really like flexibility, incredible flexibility to use each tool for whatever you need, or maybe you have teams in your organization that for some reason like Go, and other teams that for personal reasons like Elixir, and you can make both concur, no pun intended. So best tools for each need. Also, there's another, if you work with distributed systems like I do, containers are a very important piece of software or infrastructure out there, right? So unfortunately for the Elixir community, most of the work in containers is done with Go. So, and let's say Docker, say CoreOS, say Kubernetes, say whatever you like, most of these tools are built with Go. So the interaction, the adoption is see-through, is transparent with Go. So I'm not saying that when you build Elixir tools that you cannot use all of these resources, but the integration is not that simple or available, you know? So, but the beauty of this is that you can use both for whatever your needs are, in case you need both. I mean, in my case, and going back to my first statement, the spoiler alert that I'm still using Go as a full-time job, in my full-time job, is because we really haven't needed, as a team, not as a person, to go outside and look for Elixir resources, but only because my teammates have been super skilled at getting around fault tolerance, and not with tacos and not with patience, but with real solutions, you know? So, but that doesn't mean that I wouldn't like. So the problem right now that I see from my perspective, I don't know if all of you here work full-time with Elixir or would love to, but it doesn't depend on me. You know, I don't have a company, I don't own a team, I don't own a product, and I'm not planning to do that right now. So just being part of teams, and well, the consensus has been Go. So I don't know, just a side note, I would love that us as an Elixir community, now I'm counting myself as one of you, can do things to improve this situation, you know, because I would really love to, and because as I've said, like there are many talented Go programmers like that even work at Google at the Go core team that are not even aware of all the things that Elixir has built in, you know. So I don't know, let's create more awareness, let's create more projects, amazing projects to make everyone more enthusiastic, so that my next boss will allow me to work in Elixir. So thank you.
I'm sure you've got some questions. If you've got a question, come up here to the mic.
I think he has a question.
Anyone? So come on up. We'll line up right here. We need some Jeopardy music or something.
Hello. Hi. So I was just curious if so this sounds like a complete love story, and that like you just fell in love with Elixir and everything was like, you know, birthday cakes and sunbeams from the beginning. I'm curious if after you started with it, there were any points, whether it was like lack of third-party libraries or anything, or confusion with the syntax, whereas Go syntax is really familiar if you're coming from a C language, a C-based language. I'm curious if there were any points where you started to second-guess your decision, or you, after like an initial sort of like honeymoon period, there was like a valley of despair where you kind of struggled and regretted it.
I didn't go through that, but only because my journey to Elixir was not based on pressure. I did it like for a side project or for small pieces of software for my day job. So I wasn't really pressured into that, but I think that had I been in another situation, it would have been more difficult. Now, this is my experience, but also when we decided, like in my former team, when we adopted Go rather than Elixir, well, this was the case for the rest of my peers, because they were like, I'm really not getting OTP, I'm really not getting the syntax, because, you know, I really like Elixir for many reasons, and it also reminds me of when I went to school and I learned about Racket, about all these languages that you never get to use in real life. So it was like a nerd thing for me, and I got excited. But to be realistic, like as I've said, for many people that work nowadays in software development, that they didn't go to school, they don't have like all this background, and that's super cool. It might be more difficult for them. So yeah, I think so.
Awesome. Congrats on the gig at CoreOS, by the way.
Thank you.
So I've looked a bit at Go, just in the past, and wrestled with understanding coroutines coming from Elixir. Any tips on how to think about the difference between coroutines and processes in the context of Elixir?
Well, I would say that they're pretty much the same, don't kill me, but from the perspective of understanding the abstraction, yet the power of them in Elixir are more powerful. For the fault tolerance, for communication, both are designed, as far as I understand, and in my work, both are designed for concurrency. But Go is super cool for individual concurrency, say individual for a person, or individual for a system, or individual for a cluster. But communicating like between this at any granular level gets more complicated, and Elixir tackles it like perfectly. So yeah, they work similarly, I'd say, but Elixir processes are more powerful.
Hey, wonderful talk. It's really great.
Thank you.
I really love the idea of looking at tech decisions from the constraints in different parts of the world. Obviously, a lot of the thinking is very centered on like development in the U.S. among a lot of programmers. I'm curious. You said that there was like basically no one wanted to pay for servers, but you were able to adopt Go within at some level of your agency. I assume you were able to get that past like a technical manager. I'm wondering if that's maybe a different, maybe another difference. I know that like in a lot of places in the the US, there's a fear of adopting a newer language like Go or Elixir, just like where are we going to find the programmers, and like also just like, there's more conservative also because programmers are really expensive as compared to servers.
Yeah.
So,
No,
anyway.
no, you're totally right. But actually, this is shameful as well, but a positive thing of your boss not being technical is that he doesn't know what is Go and what is Python. So, yeah, no, we had to make those decisions because we stopped sleeping. We stopped, going to lunch, because we were woken up at 3 a.m. with the alerts and stuff like that. So we just decided, let's do this. We didn't replace everything, but in the end, we told him, and he was like, okay, let's do, but yeah, we had to keep it in secret for a long time. Thank you.
Okay, thank you so very much.